Okay, so well, it is time to start the webinar. First of all, thank you very much to everyone that is attending the session, especially to our speakers that I will introduce in a short moment. Well, as you know, this is a webinar coming from the ALFA project. Its name is Waste to Energy, Opportunities and Challenges of Biogas Plants. I'm Daniel Matilla from Sustainable Innovations. We are part of the ALFA project. We specifically manage the Spanish hub. And here we have as well our partners from Pedal that I will introduce shortly. Well, about this session, the most important part to know is that you can always interact with the speakers. We will open a final session with Q&A. So at any moment that you have any doubt or any question for the speakers, you can type it in the chat preferably, but also in the Q&A section. I would recommend you to use the chat as it is the most comfortable to be used for me, to be honest. Sorry. So the agenda, most of you, I assume that you've seen it, but anyway, I will go through it quickly. We will have a welcome and introduction that is already happening. That I'm doing the first minutes, and then Stania and Carolina will explain further. Then we have David Kanso from Slovakian Biogas Association. He will do this speech on waste to energy, opportunities and challenges of biogas plants. Then we have Andres Fries from Agricomp Bohemia, and he will do those two speeches that are 10 minutes each about biodegradable waste processing technologies and biowaste as biogas plants feedstock using a practical example. As I said before, we will open a Q&A session after the two speeches, so all the questions will be answered by the end of the session. I would appreciate to our speakers to not to answer the questions in the chat, just to wait, and we will answer all of them by the end of the session. For the attendees, if you have any question which is addressed to a specific person, please say it in the chat, because it will be much easier if you clarify. For example, you say for David, and you formulate your question. Being said that, I would like to introduce my colleagues from the project, from Pedal Consulting. The first of them is Stania Druskova. She's the hub manager for the Slovakian hub of the ALFA project. And then we have Karolina Mendelova, who is the deputy for the hub, the Slovakian hub as well. I will give the floor to them as they can introduce themselves much better than I can. And well, again, a warm welcome and thank you very much. So, Stania, the floor is yours.
Mm-hmm. Thank you, Daniel. Good morning and heartily welcome on my behalf as well. I'm Stania, and as Daniel already mentioned, and together with my colleague, we are working for Pedal Consulting, which is a Slovak consultancy company focusing mostly on development and implementation of European projects, mostly from Horizon Europe program, and we are different sectors orientated, so we do a different kind of project. As Daniel already mentioned, we do represent a Slovak hub within ALFA project. Carly will tell you more about the project itself, but I do have a honor to welcome among us and introduce you our two special guests, our speakers, who will be talking on the topic waste to energy. So first speaker is Mr. David Kancho. Mr. Kancho, he studied communication in Jönköping University in Sweden with a focus on sustainability. During his studies, he conducted in-depth analysis of educational programs centered around renewable energy and green technology. His passion for this topic accompanies him during his whole professional life. Post-graduation, he collaborated on biowaste collection campaigns in our capital, in Bratislava, and he was working closely with the biogas sector. Currently, he's serving as the Secretary General for Slovak Biogas Association, which is voluntary, independent, and non-political organization focusing all its efforts to support the biogas sector in Slovakia. Our second guest is Mr. Ondrej Frič. Yes, second. I don't know it by heart. Mr. Frič, who graduated from Brno University of Technology, Civil Engineering and Building Construction, has more than 16 years of experience in the renewable energy industry in the field of biogas, and he currently works as a business director within Agricomp Bohemia company. He's also Chief Sales Officer for Czech and Slovak market, responsible for sales of biogas plants, repowering and services, responsible for subsidy projects and marketing of the entire company. He also manages research and development projects. He's fluent in 4 languages, and he's also executive director of the first biomethane plant, Rakvice, in South Moravia in Czech Republic. Big thanks, gentlemen, for coming here today and share your knowledge and experience. Now I will pass the floor to my colleague Carla, who will tell you in a few minutes a bit about ALFA Project, and then we can go to the first waste to energy presentation. Caroline, the floor is yours.
Thank you, Stani, for giving me the floor. I would like to also welcome you on my behalf. I would like to tell you a few words regarding ALFA Project and to which this webinar is organized. I believe most of you who are here today with us are familiar with ALFA and our activities, but if not, next slide, please. ALFA Projects is an international project funded by European Union under the Horizon Europe program. It's a 3-year-long project, and currently we are in the third, so the last year of its duration. The overview or the main goal of our project is to support the market uptake of biogas production technologies that use manure as the main feedstock for the biogas plant, as well as to increase the share of renewable energies in Europe and also help to reduce emissions from the untreated manure. Next slide, please. Our consortium consists of 10 partners from 7 countries, and we have established 6 regional hubs. Among our partners, we have partners like European Biogas Association as well as European dairy farmers. Next slide. Currently, I would like to point your attention to some of our activities which are ongoing. So from 1st November, we have started the second open call of ALFA business and technical support services, which we will be offering for you. You can apply it via the ALFA engagement platform with the link on the slide or after scanning the QR code. We are offering currently portfolio of 11 services such as market research, access to financial support, consultancy on implementation of biogas solution technologies, and many others. You can find all the information on the engagement platform, where you can also register to receiving this free of charge support. Among our activities, parallel with that, we are also undergoing different capacity building activities with our partners. We are organizing regional seminars, online webinars like this one, as well as running awareness raising campaigns, especially via social medias to improve the perception of biogas among public. Next slide, please. I would like to point your attention to also our engagement platform, which is online platform developed during our project, which offer various tools which might be interesting for you. On this platform, you may find, for example, decision support tool, which is like an online calculator, which after you put your information in, it can calculate you the profitability and benefits of biogas solutions for a specific project. Then you can find there an atlas map, which showcase you successful biogas projects among Europe, as well as you can upload your own successful story. Then a knowledge center, which is like an online library, which provides you many information all about biogas in one spot, and as well as a biogas forum, which is like an online discussion platform. So all of these you can find on the engagement platform or after scanning the QR code on the slide. I believe that's all from my side. Now I would like to give the floor to our first speaker, Mr. David Kančo from Slovak Biogas Association, who would like to tell you a few words regarding the opportunities and challenges of biogas plants. So David, the floor is yours.
Thank you for the introduction. So welcome everyone. I will try my controls first.
Yeah, it is working, David. I think you can pass the slides now. Yeah.
Okay. So thank you for joining us today to discuss the huge potential of biogas, not only in Slovakia and Czech Republic, but also in the other countries of European Union. My name is David Kančo, and I'm here on behalf of Slovak Biogas Association, where we believe that the biogas holds a transformative role in the future of sustainable waste management and also renewable energy. So okay, I guess I'm not controlling. Okay, so try to go back. Okay, our team at the Slovak Biogas Association, we are basically a diverse group with our specific areas of expertise, from technical operations to policy advocacy, also communication. I'm trying to go back. It's not working. Don't know why.
Sorry. Yeah, you need to press Control again. Yeah. Now it should be working.
Yeah.
You
I'm
control.
trying to
Sometimes
go back.
it takes a few seconds.
Yeah. Trying to go back, but it's going forward. So yeah.
If you press the back arrow in your keyboard, maybe.
Okay.
No.
Yeah.
Okay. I will go back, and then you can start from there.
Okay. Okay. Now it's working. Okay.
Yep.
Get it.
Okay.
Sorry.
Yeah. Now you need to ask for control again. Sorry.
Yeah. Okay.
Yep. Now it's working.
Okay. Yeah, basically, since 2018, we are members of biogas European Biogas Associations, and we also work with other important associations in Slovakia to highlight the importance of the biogas sector in the economy of Slovakia, not only in Slovakia but also in our neighboring countries. So our member base, we have 50 members, which are solely biogas plants. In Slovakia, that is majority of working biogas plants. We have the overall number is around 80. So we are not a huge industry compared to other countries such as Germany or Italy. But the recent growth in the numbers of biogas plants in Slovakia is happening mostly because of the existing support for the transformation or upgrade to biomethane, to producing biomethane, and we we wait more projects in upcoming years, either biomethane projects or biogas project as well. So we have also associated members. These seven companies work towards have interest in developing the biogas sector. So we are closely working with them and also discuss the policy and some regulations when we need some things to and technical advices. We also have our partners to talk this through. So you can go next slide. So what do? We work in multiple domains: the technical assistance, regulatory advocacy, stakeholder engagement. We collaborate with the key national and the international partners who share the mission of developing the biogas, including government bodies. That is very important, and the research institutions and industry organizations. We also work on the development of social awareness. In the past years, it has been increased significantly, which is very good. Okay, maybe the overall structure of the associations. We have specialized working groups, 3 working groups focused on energy, biomethane, and environment. The energy group focused on heat and electricity, energy as well. Basically, each group covers practical issues and the regulatory landscape as well. We are trying to address both technical and policy perspective. We also prioritize education and public relations activities, promote understanding of biogas, as I've already mentioned. Here we can see some examples from our field visit to biogas plants across Slovakia, and not only Slovakia, Austria, Czech Republic, and Germany as well. We are looking for partners, so if you are interested to work with us, just let us know, and we can pay you a visit or invite you to see our biogas plants in Slovakia. And this is the example. Yeah, these are some photos from our last week conference in Zvolen, basically the middle of Slovakia. It's a huge highlight. Brings together experts and stakeholders to discuss emerging trends in the sector, also challenges. We can see there has been a discussion of people from the ministries. So it was I think it was a very successful event. Some more things for our activities. We visit, in a recent years we've registered as a European cluster collaboration platform. This opens up new possibilities for us to collaborate on waste management strategies, biogas solutions with other countries. We also contributed to the forming of Slovakia's national energy climate plan. We are advocating for the inclusion of a dedicated strategy for biomethane and biogas. Currently, Slovakia lacks such a strategy, so we are working towards that. We work also with the various universities across Slovakia and with associations from Czech Republic in the biogas sector. So what's the current status and process on what are the processing challenges of biowaste in biogas plants? Not only in Slovakia, because this is a global thing. So when it comes to the biowaste, especially in Slovakia, according to the analysis, it constitutes approximately 50% of the municipal waste content. So the overall separation remains poor. This waste mostly ends in the landfills, so releases CH4 into the environment, which is definitely not what we want. What does the biogas plants offer? It's a national solution through anaerobic digestion. It can efficiently convert biogas. It can efficiently convert biowaste into the renewable energy in the form of electricity, gas, or heat. When we talk about composting, there are also other ways to process the biowaste, like composting. So biogas production also generates valuable energy, making it slightly more sustainable compared to the composting, since it offers also material and energy recovery compared to the compost. We also have to talk about the transport distance, because processing biowaste locally within 50 kilometers of its local source is, according to our opinion, both very ideal for economic reasons and to reduce environmental impact as well. You can go next slide. Yeah, so I've already mentioned some benefits of the biogas plants extend far beyond waste reduction by producing green electricity, heat, biomethane. Additionally, the biogas plants provide critical support services for electrical grid, which is very new topic in Slovakia, and a huge number of biogas plants have an interest to provide the support for the electric grid, the flexibility. There's also a digestate, which we consider to be a very quality fertilizer. It of course depends on the feedstock you are trying to put into the biogas plant, but overall there's more than 10 years of experience in the Slovak farmers which are successfully applying the digestate and increase their yield. So at the present situation, there's 33 biogas plants in Slovakia. They process approximately 200,000 tons of biowaste each year. Interest in biowaste processing increased not only in Slovakia but across the whole EU. It's driven largely by the Renewable Energy Directive and the trend of upgrading older facilities to produce biomethane. Basically, the biomethane is the purified form of biogas and can serve as a substitute to fossil natural gas, which is an exciting development for the sector and can meet the target of European Union and REPowerEU. In Slovakia, however, transition is also motivated by the upcoming expiration of the feed-in tariff scheme, and that will happen between 2025 and 2028. That's the end of 15 years of feed-in tariff that started in 2010, and the last biogas plant that will be supported for the electricity production from the feed-in tariff will be in 2028. So these biogas plants are trying to find and explore alternative routes to generate some revenue, and the associations is actively helping in finding these ways. We also work on the waste management strategy and action plan. There's a new plan of the Ministry of Agriculture and Environment to create a waste management roadmap which is something Slovakia desperately needs, since our data for creating the biowaste across the country are insufficient. This is a huge setback when it comes to the giving the actual and reliable source of data for biogas plants to find the source of the feedstock in the form of biowaste. So we've conducted, we have a map online on our website. It's an interactive map. We have a map of Slovakia. Here are the permits for the biowaste treatment up to 5,000 tons per year. So we can see they are distributed, focused more on the west side of the country. The one blue dot you see is one existing biomethane plant. Since 2022, it is injecting the biomethane into the gas grid. The other yellow are originally agriculture biogas plants, which are also focused on processing the biowaste. And here are the permits for the biowaste treatment over 5,000 years. So if we align, we can see that the area of Slovakia is kind of covered. Slovakia is not a huge country, so approximately 50 to 60 kilometers to each biogas plant from a lot of points in Slovakia, a lot of cities. Here we can also see the orange dots. These are originally waste biogas plants. So we have originally 3 in Slovakia, and the fourth biogas plant is focused on the biowaste, is being right now commissioned. So we have the numbers. There's 18, 15, 7. I didn't mention. I forgot to mention hygienization unit. So these plants are with the hygienization unit. The hygienization or the pasteurization is necessary process to work with the biowaste from animals, and it is necessary for the biogas plant to have one if they want to process something that was in a contact with meat or that kind of biowaste. So these are the numbers. So the analysis, it basically reveals a shift towards greater use of biogas, of biowaste alongside traditional energy crops, which was the primary source of energy feedstock for biogas plants in Slovakia. Over the past 3 years, the proportion of biowaste used has grown significantly, indicating that Slovakia's biogas plants are increasingly aligned with circular economy principles, and but however, there is still a lot of space to improve. So we can see that there's 200,000 tons per year approximately in a year of this year and last year as well. Okay, we can see also biogas energy yield graph. This basically indicates the types of feedstock biogas plants have the interest in. So the first are bakery wastes, which has the highest yield. Then there's fats, meat waste, followed by maize silage and haylage. Important also are the bio waste. We can see that the yield is approximately 100 cubic meter per ton. This is not it's not a fixed number. It also bio waste is very specific when it comes to the yield because it is created from different inputs. So it's also very important to not take this as a fixed number. To ensure the quality of feedstock, biogas plants strictly use hygienization, as I've mentioned. I think Andre will talk more about this, so I guess I will just skip this slide and go to the feedstock that can be processed by biogas plants. So ideally it is a kitchen waste, restaurant waste, oils, fats, food from shops. These are all the feedstocks that can go to the biogas plant and can be processed there. Considering the fact that the biogas plant has the technology for these, there are also animal and plant byproducts from slaughterhouses, dairies, byproducts from mills, bakeries. So it is possible to work with this on biogas plants. What biogas plant cannot process is basically paper and paperboard. It can be processed, but the yield of biogas is so low that it would be useless for biogas plants to take this kind of waste, and it is more efficiently used as a to recycle or maybe to maybe some other end use than the biogas plants. So wood is also not very good feedstock for a biogas plant, since it can damage the technology, as well as foliage, dry grass. These are all the feedstock that should go directly to the composting plant. So what are some challenges that I've mentioned already? There is a need to increase the numbers of biogas plants in Slovakia, not only in Slovakia, but also in the neighboring countries. There is just too low number of them. In Slovakia, there's a huge problem in waste management information system that should follow the creation of the waste in the Slovakia, and thus gave the access to the biogas plants to find valuable sorts of the feedstock. And there's also a huge need to invest in the technologies for biogas plants, which also these investments are mostly on a state in Slovakia. So we are waiting for also subsidies and things that can improve the situation in Slovakia. There's also a composting plants versus biogas plants. According to our thought, these should never be in like opposition, but working together, as we see, for example, in Austria, in Italy. Slovakia does not have this kind of history building biogas plants next to the composting plant. So we are trying to be inspired by these countries I've mentioned. Low level of cleanness of sorted waste I've mentioned already that can bring huge problems to the biogas plants and the production. Lack of market for digestate, that's also a challenge that need to be overcome. most of the digestate is used by the agricultures to their own land. So there's a really low chance that they can sell the digestate. So with this idea, some new pilot projects are being developed in Slovakia to use digestate as a part of some new fertilizers, organic fertilizers that can have a higher value, not only economically but also for the land. Yeah, and there's also a transformation into the biomethane based on a renewable energy directive. So that's what we are trying to achieve right now in Slovakia, and grow the only one biomethane plant so far we have. I think the next year should be 2 new projects launched. So we are happy for this. So yeah, as I've mentioned, biogas plant can offer possibility of stable long-term waste collection, since they need continual entrance of feedstock. Digestate separate, which is basically separated part of the digestate. It's basically organic fertilizer, very good for agriculture land, and yeah, years of experience in the application of digestate. So if you have any questions, I will be glad to answer, and thank you for your attention.
Thank you very much, David. Well, as I said before, if you have some questions for him, you can ask them through the chat or through the Q&A section, and we will answer them at the end. Very interesting presentation. Thank you very much. And I will give the floor to Andrzej. Yeah, I think you can control now the slides and you're ready to present. So thank you very much and a warm welcome.
Thank you, Daniel. I will try it. Yes, I can control. So, good morning, ladies and gentlemen. Ondřej Frič, I am sales director from Agricom Bohemia, responsible for the Czech and Slovak market. And let me introduce you technologies for the treatment of biodegradable waste. Here's the agenda of my presentation. So let's go to the localities first. I will show you the same map, but explain the different numbers which I have there. Today in Slovak we have more than 100 biogas plants and 2 biomethane plants. One is running, one is almost ready. So soon we will be 2 there. But more than 20 plants are temporarily out of service in Slovakia. There is a guaranteed feed-in tariff for electricity. This tariff is valid for 15 years. And first biogas plants will be out of this tariff from next year. In Czech Republic is the situation a little bit different. We have more than 600 plants and 10 biomethane plants. Guaranteed feed-in tariff is for 20 years, not 15, but 20. So first projects will be out of electrical subsidy since 2028. Majority of the plants in Czech Republic and in Slovakia are agricultural. And in Czech Republic, we have 12 pure big waste treatment biogas plants. So 12 big projects. And in Slovakia, as David said, 3 big projects for waste treatment in biogas production. Regarding the feed-in tariff, there exists one in Czech Republic for biogas power plants constructed until the year 2012, which is 175 euro per megawatt hour of electricity right now. And one special tariff for biogas power plants from year 2013, which is lower at the level of 153 euro. In Slovakia is a situation much more better. The price for electricity in feed-in tariff is much more higher, 220 euro. But the problem is with the length of the operational subsidy. It's shorter than Czech Republic. Regarding the technology distribution regarding the two big technologies in anaerobic digestion, there is a dry fermentation and wet fermentation. Both technologies has advantages and disadvantages. From the point of view of substrates, much more better is dry fermentation because you don't have to care too much about the quality of substrates. But from the point of view of energy production, wins wet fermentation. Let's take an example with 30,000 tons of bio-waste, from which in dry fermentation we can make almost 4,000 megawatt hours of electricity per year. In a wet fermentation, we can treat various materials, but not too much complicated. David, we can manage also the dry grass in this technology without problems. And regarding the production of the electricity, it's the production doubled. So from the same amount, 30,000 tons of bio-waste, you can produce almost 8,000 megawatt hours of electricity per year. The plants can be divided into agricultural and waste treatment plants, and principally all of them can feed wastes. But there are some technical and legislative limits. In agricultural plants, principally you can feed plant-based wastes. In waste treatment plants, you can feed everything what you want, but if you feed substrates containing animal byproducts, you have to add a hygienization unit there. Here are the examples of suitable waste. It's a food waste, and from the pictures, you easily can guess where is the biggest problem in the food waste. It's packaging. So luckily exists technologies for depacking and for getting rid of these unwanted impurities to produce high quality biosubstrate for anaerobic digestion, and technologies which can remove the packaging and other solid materials out of the system. Here I want to thank you, Peter Benko from Inex company, for his examples. On following pictures, you will see different technologies. First picture is hammer mill. It's a big, robust crusher which can destroy almost everything. Crushed material. It's mixed, so it's together packages and biomaterial. And for the same purpose exists also simplified solutions which are not so strong but much more cheaper. These are these manual blendings and cutting pumps which can be also used for disintegration of the inputs. Screw presses technology are used for dewatering and separation of packaging. It can separate perfectly liquid and paste materials such as yogurt in package or milk in Tetra Pak box. Here you see the block diagram of typical process in packaging of food waste. So there is some waste reception tank from where we load the material into separation mill. The separation mill destroys everything. Liquid waste goes to one side, wet packages to second side. These wet packages can be additionally cleaned in the device, which looks like washing machine, and could be cleaned there, and but don't has to be. With the material, you do screw pressing and get unwatered packages, which can then serve for example, energetical purposes for burning. Liquid waste goes then to hygienization, and finally can go to the digester, even to the waste treatment plant or agricultural plant. On the picture, typical layout of the preparation of waste for AD technologies. Everything is in the big hall, indoor solution, because the potential smell should be reduced from this technology. There is a waste reception pit, then separation mill, hygienization tank, and also container for waste packaging. On this picture, you can see waste reception. As I said before, it has to be always indoor. The reception hall should be ventilated. There should be air filtering, and usually there is a big biofilter outside of the hall, which cleans the air. The barrel solution you will see in another example. Here you see the input and output from the hammer mill. It's really robust and durable technology, which can destroy almost everything. It can destroy hard plastics, metals, ceramics, bones, woods. As I said, almost everything. On these pictures, you see the final bioproduct, which is used for anaerobic digestion. These are the two lower image, and the upper image demonstrates the separated packaging from food waste. Hygienization unit. Here's example from Landia company. It's a big boiler where you have to boil the waste which were in contact with animal products, and this material should be crushed to 12 times 12 millimeters and should be boiled at least 1 hour for 70 Celsius degrees. Then it's veterinary and hygiene safe. Let me introduce you one example from the practice. It's plant Všebořice in Czech Republic, in Ústí nad Labem. We construct this plant and it's running since 2013, so more than 10 years. And it's a semi-waste treatment power plant and semi-agricultural plant. This plant has a CHP unit, which can produce 550 kilowatt of electricity per hour. And here are the substrates. So you can see that we feed their agricultural substrate. It's a green and brown substrates. Food waste, purple color, and let's say industrial waste, glycerin and lanolin. Together from these materials, we can produce stabilized digestate, which can be which is applicable to the agricultural ground as a high-quality fertilizer. We produced almost 1.8 million of cubic meters of biogas per year, and from this biogas, we can produce more than 4,000 megawatt hours of electricity. So you see in the formula that is running almost all the year, 95% of the year, and 7% is technological self-consumption of electricity for the plant. Let me introduce you the hygienization technology there, or the waste, food waste reception technology. There is a big reception hall. In the reception hall is a barrel warehouse and cleaning of the barrels. The food waste is transport from restaurants and canteens by these, I think it's 50 or 60 liters barrels. In the ceiling, there is a big ventilation, which is connected into the biofilter outside of the building. And at the end of the building, there is a reception. So it's a coarse sieve on the floor. And this skew part, it's a screw which transports the material to another room. In the second room, on the right side, you see a skew screw, which transport the material to a running belt. There is a magnet on the running belt in the center. Running belt is there for a visual control and for a possible manual separation. So possible knife or fork, it's detect on the magnet, but possible towel, let's say, from the restaurant should be controlled visually and manually separated. The blue thing in the center is a crusher, and under this belt or under this crusher, there is an underground tank where falls crushed material. This is the detail of the crusher. It's difficult to set it correctly. When we start the operation, the biggest problem were tangerines because they were jumping on the tubes and it was really difficult to set it. The crushed material then travels by pump to a hygienization tank. We had 2 parallel tanks there. We have to boil the material at least 1 hour for 70 degrees, but reaching this temperature took, let's say, 8-10 hours approximately. This material then, when it's hygienized, can be pumped directly to the anaerobic digester, and the project has also a system of side pre-pits for dosing of another liquids which doesn't have to be digested, like lanolin and glycerin, which I mentioned. Some of these pits are preheated. It's visible on the left side, white pipes. This is the very simple technological scheme of whole system. And the center pipe between green and blue hygienization tank goes to the digester. Here I have a short video for you. So it's a reception hall. This is the sieve for reception of and sieving of the materials. This pump pumps the material to the hygienization unit from the underground tank, skew screw, running belt, magnet, and finally the crusher here. And the material ends here in the hygienization tank. Well, this is the helicopter view on the plant. The white house in the center is the hygienization unit. Second smaller house is a machine house, 2 digesters and 1 storage tank. And this year we are working on the expansion project, and I hope soon this power plant will be double-sized soon. So let me go to the future of biogas sector. There are 2 paths. One is modernization and continuing in the CHP production, and the second is repowering to the biomethane. CHP biogas plants has possible to do the modernization in Czech Republic and also in Slovak, as already David mentioned. Exists some recovery plan which can give you governmental money for your project. And definitely future for CHP plants are savings on inputs, because there is no more future in energy crops right now, and waste materials will be very important for the plants for their future. And again, repetition of David's information, flexible energy production and power balance services is definitely future for the plants producing electricity in CHPs. I will show example of modernization of the plant, which we did or we are finalizing right now in Velké Lipňany in Slovakia. It's a plant where we add a big gas holder on the storage tank. Because of this gas holder and the heating of the storage tank, we increased the fermentation capacity. So now we save around 15% of raw materials, and we have enough energy for the power balance services, for example. And from the savings, yes, this is the interior of the tank. This picture is 1 month old. Today, we start to fill the storage tank with the digestate already. And with the savings, we produced some excessive electricity. With this excessive electricity, we can cover a technological self-consumption of the plant and also other electricity consumption of wood drying technology, which is nearby the plant. This project costs almost 1 million euro, and 60% was supported from the renovation plan. In the center, you'll see the additional third CHP unit, and on the left side, the original 2 CHP units in a house. In Czech Republic, we are working on right now on a design of municipal waste biogas plant. Very interesting project, a little bit different. There are not too much municipal plants at all. So we are working on this. We are in the feasibility study right now. We consider different solutions. I hope there will be a biomethane production with CHP unit. We will see. And this project should work with the restaurant waste from maintenance of the green areas, from the public biowaste collection, and also with energy crops. To the biomethane, generally, in my branch, this is the most sexy topic right now. Definitely, everybody wants biomethane. There are a lot of subsidies in all countries across the Europe. There is a growing free market. Unfortunately, feed-in tariff in Czech Republic is insufficiently high. So we are sad, but Slovaks are more sad because they miss the feed-in tariff completely. They have to work with trading on the market. In biomethane, it's important to mention that biomethane directly depend on substrates. On the left graph, you see the carbon footprint of different group of substrates. And on the right side, the price in euro for 1 MWh of energy in biomethane. So many wins. Biowaste is very interesting. And energy crops biomethane has a similar price, but it's a little bit different to sell it. Difficult, sorry, difficult to sell it. On this example, I just want to demonstrate that a lot of plants, biomethane plants, are made as a modernization of original CHP plants. And if you do the modernization, you add some technology, and this technology usually have big compressors because membrane upgrading technology is most popular right now for small projects in Czech and Slovak. If you do the modernization, your electricity consumption, self-consumption grows 20% higher. If you want to compare the prices for electricity, and I hope you remember the price in Slovakia, 220 euro, as I mentioned in the beginning, you have to consider the different efficiencies of a CHP unit and upgrading unit. And if you do the energy conversion, you got two magical numbers, 2.5, which is the efficiency number, and 1.2, which is the higher self-consumption of electricity. If you do the calculation, the equivalent price for biomethane calculated from electricity is 106 euro per megawatt hour in biomethane, and today price of manure biomethane is 110, waste biomethane 89. So here is the answer why in Slovakia are so less plants today. But this state will last only for 1 or 2 years, I hope, because the electricity subsidy will end there. This is the example from Czech Republic. It's a plant from 2013, which I'm operating. We did their modernization this year. So now we have a biomethane plant. This biomethane plant is connected to the gas grid, gas network. The connection is quite short, 600 meters, and we are able to inject around 110, 114 cubic meters of biomethane per hour today. We produced biomethane 100% from the manure. We use cow manure and chicken manure. We have very, very low CO2 emissions, minus 104. And we sell now electricity, and it's one package, and in second package, gas, guarantee of origin, and certificate of sustainability. What is perfect is that our revenues grows with the biomethane by 40% if I compare it to the electrical sales last year. This is the example of pretty new plant we are working on right now in Agricomp. It's a completely new plant in Krakořice. It's a small village close to Olomouc in Czech Republic. This plant is completely new, capacity 500 cubic meters of raw biogas, and we are almost ready, technically finished, doing the first revisions and tests, and I hope in December or in January we will be ready to start the trial operation. Please follow us on the YouTube channel. There are some videos from this site. And finally, I'd like to show you this picture. And my question is whether it is still waste, already waste, or still food. This material officially is food waste for biogas plants. For me, it is food. When I see this material, I take some fruits and vegetables for me for eating. It's no problem to do it. On the paper, it has a zero carbon emission footprint. It's not true. We are lying we are lying in these calculations. And from the social point of view, it's a most expensive fuel for the plants. So please minimize the waste, think about it, act responsibly, and try to avoid waste production. Thank you for your attention.
Thank you very much, Ondro, and also David, for your excellent presentations. We are over time, but we do have 2 questions within Q&A session. So the first one, I don't know for which speaker it is for, but the question is: can food waste, such as bakery byproducts, be efficiently processed in biogas plants? Additionally, is it common biogas plants to pay for such materials, or do waste owners typically pay for the processing service, and how much on average? I don't know which one, maybe.
I think it's for me.
Okay, go ahead.
It is like Bakery byproducts are very good. There are not too much of them. But if you took this directly from the bakery, not from the shops, you have an advantage that you can avoid the packaging. Yeah, so for example, me in Rakvice, I'm buying the bakery from Penam company, and I buy roughly 5 or 10 tons per month, so really small amount. The material is out of packaging. Uh, there are rolls, breads, cakes, pastry, flour, everything together, but always without packaging. And I pay 1,000 crowns per ton, so it's 40 euro per ton of this material. And it's really good. It produces a pretty high amount of gas with comparison to the corn silage, let's say double. So roughly 400 cubic meters of raw biogas per hour.
Super. Thank you, Andra. We do have 2 more questions. The second one is comprised of 3 questions. Can Malawi, I think the state Malawi, participate in this program? If so, how can that be? Can you share the business model on how biogas plants work? And how does the program keep the efficiency of sorting of waste high? I don't know what program are you referring to. So maybe if you're talking about ALFA project, it's usually just only for European Union countries as it is funded from EU. But with regards to business model, I don't know, maybe David or Ondra, do you have any business
Yeah,
model?
I could maybe elaborate on this. Basically, it shouldn't be a problem to share like a business model of a biogas plant, but it is important to realize that we are talking about Malawi, and our biogas plants are located in the center of Europe. So maybe the business models will be probably very different in order when we are speaking about the feedstocks, for example, and that is a huge difference for maybe the point of view what you can put in the biogas plants in the Malawi and what we are working with in the Europe. So I don't know, maybe Andre can have something to add, but yeah.
I have a lot of experiences with African projects. In history, we have one project in Kenya in Agricomp, which was done by our Agricomp in Germany. But I remember that we support only technological solutions. So the construction was made in Kenya. The whole project was designed in Kenya, and we just went there with the container of technology, do the assembly, commissioning, and left this project. Maybe if you have some more information or a list of substrates or some ideas what you want to design, we can design the project for you. But we are not experienced with the local conditions, so we can design from the technical side, but not from the legal side in Malawi, unfortunately.
Thank you. This webinar will be recorded, so you will have all the information in also with the contact details. So if you want to reach out. The third question is, what is the main reason so many built biogas plants are currently not in operation? I think it's
Yeah,
for
I think I can answer. Basically, back into 2010, the new law has been introduced in Slovakia that supported the feed-in tariff or introduced the feed-in tariff for the biogas plants, and let's say a lot of like industries or financial maybe groups saw this as an opportunity to uh, um, to earn some money, and some of these new biogas plants that has been really they have been built without a proper plan. When you will take the biogas plant, it's a uh, technical project. It needs to have uh, you yeah, you need to think before you will build the biogas plant. And most of this, you need to think about the utilization of heat, use of electricity, and many other things. And biogas plants needs to be the most efficient way where to build biogas is where it can utilize its electricity to sell and the heat to also to sell the heat. And most of these projects built that are not functioning anymore in Slovakia has been built in the middle of a meadow in Slovakia without the heat utilization, without the proper access to feedstock, continuous access to the feedstock, and that has led after several years to the collapse of biogas plant and to the bankruptcy, because they couldn't offer they didn't have enough feedstock to continue the process. So I think this is one of the main reasons why there are more than 20 projects in Slovakia that are not working anymore.
Mm-hmm. Thank you, David. And the last question, maybe for both speakers, in a short. Can a biogas plant be profitable using only animal manure? Should such a plant focus on electricity production or biomethane?
Okay, I will answer. We in Rakvice, as I mentioned, we produce biogas 100% from the manure, but it's not 100% of the biogas. It's 100% of the biogas for biomethane. But in fact, I have one digester, and there is a mixture of two biogases, like virtually. 1/3 is made from energy plants like corn, gracilla, sugar beet, etc. is 1/3 of production, and 2/3 are made from manure. If you want to digest that only manure, you will have serious technological problems and biological problems. So you have to mix it with something, and the ratio is, let's say, 1:2, 1:3, 1:4, and you can add pretty much manure in the system, but not only manure.
Mm-hmm.
And regarding the second question, if you remember the prices for electricity, there were three numbers: 150 or 170 roughly euro per megawatt hour in Czech Republic, and 220 euro for megawatt hour in Slovak. This is feed-in tariff. But from these prices, the price of electricity itself is 92 euro right now. And there is no future in a feed-in electricity tariffs across the Europe for biogas. So with the price 92 euro, you cannot run the biogas plant. It's not possible with electricity production. So if you have manure, and remember my graphs with the CO2 footprint and with the prices, definitely think about the biomethane production. With the injection to the gas grid unit, it's the most easy project. With the CNG technology, with the LNG technology, whatever, but definitely biomethane.
Okay, thank you, Andrea. David, would you like to add something?
To this question, not really, but I would like to return to the first question, because there has been it's a really good question. I really don't want to go around it. It says about it is common for biogas plants to pay for feedstock, or do waste owners typically pay for the processing service, and how much on average? So I would like to answer this. Basically, in countries in European Union, it is most common for the producers of waste to pay to biogas plants to process the waste. It's called a gate fee, and many of the biogas plants builds their business model around this. So it is possible to gain like a huge percent of the revenue from the gate fees. Unfortunately, in Slovakia, it does not apply yet. and biogas plants are still in the position where they have to basically sometimes even they have to pay for the feedstocks to buy from the producers, but this way is slowly shifting, and in the future it's probably going to be like the producers will have to pay for the for the processing of the biogas of the bio waste in the biogas plant.
Super. Thank you very much, guys. Thank you very much to our honorable speakers, David Kancho and Mr. Andrej Frič. Thanks to Daniel also for making this happen. Please do not forget to fill out our feedback form. Your suggestion will help us to improve our work in a future. Thank you, all of you who stayed with us 15 minutes due time, and hopefully we'll see you on our next webinar. Daniel, the floor is yours if you want to close it officially.
Yeah, thank you very much, Sania. Not that much to add. Again, thank you to everyone, and thank you to the attendees for staying a little bit more. But I think it was worthy. Yep, we will send sum up email with the recording of the session, the PPT, and some other resources. But I would like to make sure that everyone is aware that you can contact the ALFA project at any time with any questions, and we can also address you to other actors in the value chain. So, for example, in the question for Africa, we can look for other actors that can support you. And overall, thanking again David and Andrej for being here. This has been a really interesting session. Thank you for giving the support and for giving us your expertise. And any question we would be happy to answer. And you have the feedback form. You will receive an automatic email tomorrow with the feedback form. And in the next week, we will send all the materials coming from the webinar. That's it. Thank you very much. Have a good day. And see you in the next webinar.
Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.